Absolute value represents the distance that a number is from 0. So if I draw a number line, 0's in the middle, here's 3, here's -3. How many units away from 0 is 3? 3 units from 0. How many units from 0 is -3? 3. Distance is always positive, so absolute value is always positive. So when we are doing an absolute value equation, we have to consider that if absolute value equals something, that could be that many units from 0 in both directions. So take a look at number 1. It says the absolute value of x equals 6. So the number inside this absolute value bar could be 6, or it could also be -6, because both 6 and -6 are 6 units away from 0. So we write two equations, not with highlighter. X equals 6 and x equals -6. And both of those would be solutions to that particular equation. If I plug 6 in place of the x, the absolute value of 6 is 6. If I plug the -6 in place of that x, the absolute value of -6 is +6. So a problem like number 2, absolute value of stuff equals 5 units from 0. Where on the number line are we 5 units from 0? At 5 and -5. So you write two equations. 3x plus 1 equals 5. 3x plus 1 equals -5. And you solve both of those equations. So let's take a quick minute. We'd subtract 1. So 3x equals 4. Divide both sides by 3. One of our solutions is x equals 4/3. If I plug 4/3 into the original equation, if I go back up to the original absolute value equation up here that I'm highlighting in green, 3 times 4/3 is 3, 3 plus 1 is 4, and the absolute value, 3 times 4/3 is 4, 4 plus 1 is 5, and the absolute value of 5 is 5. If we solve the other one, subtract 1, 3x equals -6, so x equals -2. 3 times -2 is -6, -6 plus 1 is -5, and the absolute value of -5 is +5. So both of these are solutions. You would box both of them because they are both solutions to this absolute value equation. Okay, let's look at number 3. Absolute value of 2x minus 12 equals -4. Let's think for a minute. Do you remember what I highlighted up at the top of this? Absolute value is always positive. So this is saying 2x minus 12 is going to be -4 units from 0. Where is -4 units away from 0? It doesn't exist. -4 is 4 units from 0. It is not possible for something to be -4 units away from 0 because distance is always positive. So absolute value cannot equal a negative number. That doesn't work. So this would be no solutions. You're going to hope for this problem on the test because it means you don't have to do any work. If you see absolute value equals negative number, you'd be like, oh, wait, that's not going to work. What do you think we need to do first in number 4? But it's not no solution. First, we need to isolate the absolute value bars. So first, we need to add 10 to both sides. That will give us the absolute value of 3x plus 9 equals 6, +6, so we can do this. What two equations do I need to write to solve this equation? Okay. Oops. Here's a part of your notes to help you remember some of this. If it says the absolute value equals a positive number, like we had in number 2, there are 2 solutions. If you have absolute value equals 0, where on the number line are you 0 units away from 0? At 0. There's not a second location that is 0 units away from 0. So if absolute value equals 0, there's only going to be one solution. If absolute value equals a negative number, like in number 3, there will be no solutions. Next, we need to talk about extraneous solutions. We are going to look at some cases where there's an x on the right side of the equation. This is going to create 2 solutions, but one or both of those solutions might not actually work in the original problem. An extraneous solution, it even says the word extra right in there. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. When there are variables on both sides, there is a possibility of extraneous solutions. So I want to do this very strategically. Let's look at number 5. And then we're going to do number 7. Number 5, absolute value of x equals 2x plus 3. One of our equations is going to be x equals 2x plus 3. So stuff from the absolute value bars equals exactly what the right side says. For the other equation, we have to take the opposite of the right side of that equation. That means take the opposite of every term. So x equals negative 2x minus 3. Take a moment on your own, solve both of those equations, and then we will talk about checking for extraneous solutions. You should end up with x equals negative 3 and x equals negative 1. Good so far? We need to test these solutions in the original problem. Do not test them in the purple equations. They will definitely work in the purple equations because that's how we got those answers. You need to go back to the original. So if I plug negative 3 into the original problem, absolute value of negative 3 equals 2 times negative 3 plus 3. What is the absolute value of negative 3? Positive 3. And then on the right side, 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3. Does 3 equal negative 3? No. That is an extraneous solution. You have to throw it out. So cross it out, whatever you need to do to show yourself that, nope, that solution doesn't work, it's gone. Now, this does not mean that the other solution is definitely going to work. Sometimes one solution works, sometimes both solutions work, sometimes neither solutions work. So it's kind of annoying, but you do have to test both of them. So let's test negative 1. Absolute value of negative 1 equals 2 times negative 1 plus 3. The absolute value of negative 1 is 1. Negative 2 plus 3 is 1. 1 equals 1, that is valid. So x equals negative 1 is our solution. Take a look at number 7. What do you think we might need to do first? Subtract 8 on both sides. You want the absolute value bars to be by themselves before you do anything else. So absolute value of x plus 6 equals 3x minus 4. Now let's write our 2 equations. What's the first equation? X plus 6 equals 3x minus 4. Notice we didn't change anything. We just wrote it without the absolute value bars. The other equation, x plus 6, don't change the left side, equals negative 3x plus 4. Take the opposite of both terms. Now, on your own, take a moment, solve both equations, and then see if you can test it, not in the green one, go all the way back to the original one that we started with. So get your solutions and test your solutions. Hopefully you got 5 and negative 0.5. Now we need to test these back in the original. So we are going all the way back to the original absolute value equation that we started with. Let's start with 5. If we plug in 5 plus 6 is 11. The absolute value of 11 is 11. And 11 plus 8 is 19. So if I plug 5 back into the original left side, so I did 5 plus 6, the absolute value of that, plus 8, and I got 19 on that left side. On the right side, 3 times 5 plus 4. 3 times 5 is 15. 15 plus 4 is 19. 19 equals 19. X equals 5 is one of our solutions. That's a good solution. Let's try the other one. This one, I would highly recommend that you use your calculator. We are basically doing the absolute value of 0.5 plus 6 and then adding 8. And we want to know if that's going to be the same as 3 times negative 0.5 plus 4. Your calculator will help you with this. Negative 0.5 plus 6 is 5.5. The absolute value of 5.5 is 5.5. Add 8 to that, I get 13.5. Oops. On the right side, negative 0.5 times 3, and then add 4, 2.5. Does 13.5 equal 2.5? Definitely not. So that is not a solution to our problem. The only solution that actually works is x equals 5. Next, let's look at number 9. The difference between number 9 and previous problems is that now we have absolute value on both sides. You're actually going to treat number 9 very similar to how we did number 7 at the green step. So number 9 is just like number 7 at the green step. Our two equations are 5k plus 12 equals 4k minus 1. Our other equation is 5k plus 12 equals, anyone want to take a guess? Negative 4k plus 1. Now here's the crazy thing about this. If you switched those two sides, you could also do 4k minus 1 equals 5k plus 12, and 4k minus 1 equals negative 5k minus 12. You would end up getting the same answers. So it doesn't matter which side. I just like to always leave the left side alone. The right side is the one that you mess with when you're writing your two equations. Okay. Do you feel like you could then solve both of those equations and check both of the solutions in the original problem? Okay, so I want to give you some work time on your assignment. For this particular assignment, when you pull it up, it looks like this. There are 8 problems. I would like you to do the 4 problems on the left as your assignment. So 1, 3, 5, and 7 are your assignment. 2, 4, 6, and 8 are bonus problems. So that means this assignment is worth 10 points. If you do 1, 3, 5, 7, you get 10 out of 10. If you do all 8 of them, you get 15 out of 10. So you get 5 bonus points in the gradebook to help you out if maybe you don't finish half of an assignment somewhere. Really quickly, take a look at number 1. We didn't have an example quite like number 1. What do you think you would need to do first in number 1? Divide by negative 3. You cannot distribute into absolute value. I repeat, you cannot distribute into absolute value. So you'd have to divide by negative 3. And on number 7, take a look at number 7. First, you would subtract 5. Then you would divide by 4. Then you could finish